Induction, magnetic flux, Faraday's experiments, Faraday's laws of electromagnetic induction, Lenz's law and law of conservation of energy, expression for induced EMF based on both the laws, method of production, induced EMF. There are three methods. One is by changing magnetic field, by changing area of the coil, that is called motional EMF, by changing the relative orientation of the coil with magnetic field. Next, eddy current, self-induction, mutual induction. Additional information. What is magnetic flux? ये देखिए magnetic flux क्या होता है? Magnetic flux through any surface is number of magnetic lines of force passing normally through that surface. So number of magnetic lines passing through normally through that surface. You can see here over here, and you can just check it whether it is content is clear or not. If you have a doubt over here, you can send it in the box. You can send it in the box if you have a doubt. Hope all are well. Easily you can see it. It can also be defined as the product of area of surface and component of magnetic field normal to the surface. You can check it here. The animation figure is showing this is the area ds, and this is a normal, and this is a magnetic field which is in the direction shown here by the vector B. Now the component of the B in the direction of normal will become B cos theta. By taking trigonometrical function, one can easily say that d pi equal to b ds, that is actually dot product, because the flux is a scalar quantity. So it is a dot product. Dot product is magnetic field and area. If it is a theta is angle, then we can write b ds cos theta. That is your magnetic flux. If you integrate it, you will get your magnetic field and the complete area, that is BA, or you can write BA cos theta. Then positive flux depend on theta. If the theta lies between 0 to 90, it will be positive, and if it is 270 and 360 between, then it will be again positive. Negative comes when 90 and theta is 270. That is 0. At 0, the magnetic flux will become 0 when it is 90, because cos 90 is 0, cos 270 is also 0. Negative flux between 90 and 270, and you can check it here. This flux is maximum, theta is 0 and cos 0 is 1. So this is the final formula. Electric flux means how to calculate. You need 3 components over here. One is magnetic field, another one is area, and then the angle between these two. That is why we can change the flux by changing magnetic field, or by changing area, by changing orientation with theta, or any combination of above. This is the 4 methods. Why do we study about the changing? Because you are going to learn here that magnetic flux, when changes, an induced EMF is produced. That is what actually the Faraday's discovered. The entire chapter is based on that only, and you are going to see that. Right? You can see here properties of magnetic flux. It is a scalar quantity, no direction, only magnitude. It is a pure number. Next, it will be its units are Tesla per meter square or Weber. 1 Weber is equal to 1 Tesla per meter square. Or in short, you can write WB and Tesla meter square. Such unit is Maxwell. 1 Maxwell is 10 to the power of minus 8 Webers. Magnetic flux associated per unit area is called magnetic flux density, or strength of magnetic field, or magnetic induction. So you need to remember all the different technical words used for flux. One, it is, I repeat, magnetic flux density, strength of magnetic field, magnetic induction. Next, we are going to see here one experiment. That experiment is helping you to understand whenever there is a flux changes across the coil, an induced EMF is produced. In the first diagram, there are 2 coils. One is left side, which is connected with sensitive galvanometer, and right side again same type of identical coil connected with a sensitive galvanometer. In the middle there is a strong magnet, bar magnet. Okay. Now you can see what happens when a bar magnet is pushed left. So you can see here there is a deflection in the galvanometer, and even you can see in the second coil also. In first coil also there is a deflection, in second coil also there is a deflection. So, but deflection is in opposite direction. Once again you can check. Here it is south pole is pushed, and now once again you can check it here. What happened? Pushing here, north pole generated towards the north, north pole is generated towards the south in second coil. This is the experimental evidence that whenever magnetic flux of the bar magnet on pushing, there is a change in magnetic flux linked with the primary coil as well as secondary coil. Due to that, there will be an induction. That induction we call it as electromagnetic induction. Electromagnetic induction is the induction which is produced EMF due to the change of magnetic flux linked with the coil, and induced EMF is produced. Okay children, hope anyone is there online. Online streaming is going on. If you are having any query, you can put it in the box so that I can see and I reply. And if you like it, please subscribe this online physics channel. Also I am going to teach science. Also I am going to teach mathematics. So whatever the queries are there, you can just put it in the box. Comment box is available. With that you can just see here. Once again you can see. You can see here when I am pushing, the coil will become magnet due to the flow of current. That is why there is a change in, that is why there is a galvanometer which is giving deflection. Both you can see carefully, then you can understand. See, galvanometer is moving in the direction of current. Here also same thing is happening. But you notice that the coil become a bar magnet. One side it will become north, other side is south. It is marked clearly. Hope you clear it. Next. Second one you see again galvanometer, both the coil it will be deflected and forming opposite poles. South pole in it is pushed, south pole is created. So that means what? So it is opposing the south. So these are the some experiment. One more thing, it is very clearly given over here. Bar magnet which is showing the magnetic field. These magnetic fields are imaginary, it is not noticeable, it is invisible, and these magnetic fields generally it will pass through the north pole and end with the south pole, and when it is pushed, what is happening? So magnetic lines of forces are cutting. Due to the cutting across the coil, there will be a change in magnetic field. So changing magnetic field causes change in magnetic flux. So magnetic flux is changing, that time only there is a deflection. You can see here once again, as you push north pole, same thing is happening, but here in the previous experiment and this experiment is almost the same, but here is showing imaginary magnetic lines in visible condition. Okay, so you can see here that is magnetic flux linked with the coil changes relatively to the position of the coil, and due to the magnetic field lines of force cutting at a different angles at the same cross sectional area of the coil. So that means what just now I explained to you, the magnetic field lines are, when it is cutting, there will be